Hey, welcome back to Any Bit Fever Dreams. So I'm always looking for ways to make this K2 from Phoenix Retro Systems to play music and sound for the past year, and my attention has been on the SID chip functionality it has. Now, the SID, as we all know, made its debut in the legendary Commodore 64 from 1982 and almost needs no introduction at this point. The SID meaning Sound Interface Device. The K2 has two of them in its FPGA and is pretty easy to program. There are thousands of pieces of music composed for it over the last 4 decades. Wouldn't it be great to be able to easily bring some of them to here for some quick and great sounding game music? Well, I did some coding and got to this point. There's this gigantic SID file collection called the High Voltage SID collection that's been around for almost as long as the internet has been around at this point, since 1996. They've been extracting music from games and demos steadily over the last 4 decades. Surely, there's a way to learn how the files are laid out and extract the data to make it sing elsewhere, like on my K2 just here. It turns out the PSID format it uses is a little different than other easier formats, like standard MIDI files or VGM files. Those last two are easy because you basically get a timestamp delay between events, then a well-known command to know which note to play, which instrument to set up, and everything. The PSID format of the HVSC collection has some of that, sure, but it also has raw binary code that tells a C64 how to set up temporary variables at specific memory locations, so it's not easily portable to a K2 without checking what each tune is doing. You have to reverse engineer the code for every song. If that sounds like a lot of work, it's because it is. However, thanks to a very powerful idea by our community member Gadget, I was able to sidestep all of that and get straight to The trick is to not care about the code inside a SID file that's responsible for playing itself. Instead, you have to play it in an emulation environment that's able to capture the state of the 25 SID registers at every frame, dump it in a file, and you're done. If you're familiar with saved states when you play your favorite game in an emulator, it's very similar to this. You save the state of the SID 50 or 60 times a second, and all you need to program after that is to use it in a file reader that gets them and pumps them back to the SID. That's way easier than reverse engineering binary code that's different for every tune, and it's way easier than emulating a whole C64 environment. Just knowing that this idea would work landed me on this project called Zig Resid that allows just that. It loads a PSID file from the collection, can check out its header for type, speed, author, title, and emulates a C64 environment and memory map and plays it silently. It can then output its SID log to a binary file or even create a wave sound file if you wanted an audio output. After it worked, I created a pipeline under WSL running on my Windows 11 machine to automatically convert a list of SID music I remember from the 80s, so it produced these dead simple binary files. All they do is pump out 25 binary bytes of data for every frame, usually at every 1/50th of a second. My Phoenix K2 program just has to open them back up, run a timer based on interrupt 0 to get to 50 Hz level speed, and push these bytes back out to the proper registers. I added my file picker that I'm using in many other projects, and at this point, it's a library file and just has a few lines of copy pasting that I have to do. I love it when a project gets to a state of W within a few days. Let's see it in action again before I wrap this up and tell you about its limits. For the Phoenix community, I released this as psidplayer.pgz in the wiki. You can find it in the software for 6502 and the music section. I also put a bunch of converted binary files with extension .raw in this zip file. Just extract them to a folder called SID in your Phoenix SD card. This can work for the original K, the K2, and the Junior 2. If your original Junior has populated SID chips, it could also work there. Alright, so this method works for SID files that are programmed against vertical blanking of the screen, which means a new state at 50 Hz frequency or 60 Hz, depending on if it's a PAL or NTSC version of a SID tune. When you get to the other kind of tune controlled by the CIA chip of the C64, the complex interface adapter, that's when it breaks down. CIA is used for faster timing and as a C64 specific environment thing. I'm sure the Phoenix can handle these levels of timings and a translation could be done, but what I'm not sure about is if the conversion I'm doing with Zig Resid can handle logging with those cases. A notable tune that I would love to port over is stuff like Whizball that sounds like this under the SID Play 3 player in Windows. Well, that's it for now. Stay tuned for more Phoenix experiments in the future. Like and subscribe if you made it this far, and most of all, make sure to take care. Bye!